this video, we will talk about using second derivative test to determine the nature of the stationary point. So when we say second derivative, we are looking at this symbol. Okay, it basically means the derivative of dy dx, which is differentiating dy dx, and then you will get second derivative. So before we start about that, let's just take a look at this example. I sketch a minimum graph. Now I would like you to observe the gradient of this graph. So for a minimum graph, the gradient will always be from negative. Okay, so this part of the gradient is negative. Then after that, it will reach the turning point, the stationary, where your gradient is 0. Okay, gradient is 0. And then after that, it will change, gradient will now change to positive. So at 0 is only here, right? So the gradient changes from negative, so this is negative, yeah? Let me just rewrite. So this gradient is negative, and then it will change to 0, and then after that it become positive. So this is what we were trying to demonstrate. Gradient change from negative to positive. So if I were to look at this example here, okay, I draw a minimum graph. So likewise, okay, in this example, so this is y equals to negative 3x plus x squared, x cubed. Okay, so in this part, this portion of the graph is minimum, and then after that it became 0, and then this part of the graph, it becomes positive. So if I were to, so this is what we were trying to do here. Okay, now if I were to now redraw this info gradient, the value of dy dx, if I were to draw it out, so this is where it is here, you will notice that the value changes from negative, right? So this part of the graph is negative, the value is negative. Then at 1, x equals to 1, the value of dy dx is 0. Then after that, the gradient after 1, x equals to 1, it becomes positive, so it's now above the x-axis. So this is a dy dx graph against x. So what happens is that if you take a look at the gradient of this graph that we have drawn, the gradient of dy dx is basically positive, right? It's more than 0. And we have said that gradient of dy dx is basically the second derivative, and that is written in this form, is more than 0. So we are trying to conclude that if my dy second derivative is more than 0, I can simply conclude that it is a minimum point. Okay, likewise, if I were to have a maximum point, okay, I can do the same thing. A maximum point will start with a positive gradient. So because it's positive gradient, my value of dy dx will be positive. Then after that, at the turning point, dy dx is 0. So therefore, your dy dx will be 0 on the dy dx graph. Now, and then the last part, because it's maximum, the value will now start to become negative for your gradient value. So if I were to plot it on my dy dx graph, it will be negative values. So as you can see, this portion, the gradient of this graph, and this graph is dy dx. So gradient of dy dx is negative. And dy dx, gradient of dy dx is your second derivative, and it's less than 0. So with this, we can conclude that if my second derivative is less than 0, then it is a maximum point. So with this, we can now take a look at this example 1. Okay, and in this question, they ask us to determine the nature of the stationary point using second derivative test. But before that, they also have asked us to find the coordinates of the stationary points. So with this, let's do the first thing. To find stationary point, we know that we need to use dy dx. Okay, so once I have my dy dx, at stationary point, I can write down dy dx is equal to 0. So I form my equation and I will solve for x. And I will get 2x value, x equals to -7 and x equals to 1. So the question asked me for coordinates. So at x equals to -7, my y value, by substituting into here, I will get 272. And x equals to 1, my y is 16. So with that, I actually found my 2 points of stationary point, the coordinates of my 2 stationary point. So this is the first part done. Now the second part say I need to use second derivative test. So using my dy dx, which is this one here, I will now need to differentiate again, and that will be my second derivative. So when I differentiate again, I will get 6x plus 18. Now my stationary point happens at x equals to -7 and x equals to 1. So I'm going to make use of these two x coordinate, and I'm going to sub in to my second derivative. I get -24. And for -24, we know that this is less than 0. So since my second derivative is less than 0, I can conclude that -7, comma 272, this point is a maximum point. And then now I'm going to do the same thing using x equals to 1. I'm going to sub into my second derivative, and I get 24, which means my second derivative is more than 0. And because second derivative is more than 0, I can conclude that my point 1, 16 is a minimum point. And this is how we do second derivative test. This is how we use second derivative test to determine the nature of the stationary point.